So, hello everyone, hope you all are doing well. This side, Harsh Bhargav, the captain of team Aadishakti, and in this video, we will be demonstrating our hardware functionality for the ISRO Robotics Challenge. So, let's move forward.
So now comes to the structure readiness. As of now, we have completed half our work in framing, and cutting. Like here, we have mostly assembled the body part, and for the overall frame, we have made one part, and the second part is going on. The parts are done by the help of CNC. These are CNC cutted plates which will be fitted on the body and the whole body.
For the obstacle detection, we have planned on using image segmentation process. For this, we have used a Resonate 18 encoder and a unit architecture for image segmentation. We have created three models. First is a crater detection model, which will be used to detect the craters of various sizes. Second, we have created a rock detection model that will be used to detect the rocks. And the third one is a general purpose object detection model, which we will be using to detect the target object that we have to pick up and place in the robot. Till now, we have fully created the crater detection model and the rock segmentation model is in the process of training. Now, we will show you the demo of the crater detection model.
Mobility, we are using the L298N motor driver, and we are controlling that motor driver using Raspberry Pi 5 microprocessor. We have written a basic code for the motor mobility to move it forward and backward at the speed of 1 cm per second using the RPI0 library. Task is to control the speed of motor using the data which is received by the camera.
So, moving on to the next segment of our sensor functionalities, that is Intel RealSense depth camera. As we can see, our camera is working and it's giving some sort of images and video data. Like we can see here, it's giving depth video as well as RGB video also, and it's also giving some sort of gyroscopic data, and the accelerometer data is also here. So if I wave my hand here like this, so we can see the change in the depth images as well as our RGB. And if I wave the camera here and there, we can see some sort of changes in gyro stream as well as accelerometer stream. So this is the part of our sensor functionality, and I conclude here the sensor functionality of Intel RealSense depth camera. Thank you.
So now we are moving on the second segment of our sensor functionality video, that is LiDAR sensor. You can see here, this is a YD LiDAR sensor having range frequency of 3000 Hz and a distance range can vary up to 8 meters. So now let's watch how this works.
So here we can see our LiDAR sensor is working and it's mapping the whole environment. As we can see here in this graph, our environment is readily converted into the plots, and we can see here the approximate angle given by the LiDAR sensor. It's about 296 to 97 and the distance is varying. So if we put my hand there, you can see the environment is changing, the mapping is changing. So accordingly our sensor is working.